I'm a game changer. I'm a risk taker.
Hi, I'm Norfolk.
And I'm Ernest.
And we are Team Imagine Winning. We are both from Anderson Secondary School and we have participated in Noise Singapore. We also have 2 years of coding experience each. This time, we participated in the U19 RCAP CoSpace Rescue Challenge. To give a summary of the preliminary challenge, we were tasked to collect cyan, red, and black colored gems scattered throughout the map filled with various obstacles and traps, as seen in one of the example maps to the right.
For the preliminary round, we were given quite an interesting map. Firstly, the trap color was red instead of the usual cyan color we are accustomed to. The map was also mostly symmetrical down the middle. Lastly, we realized at first glance that this map had some difficult to reach collection points. This then gives rise to some unique problems, which we'll be covering on in the next slide.
Firstly, the trap was the same color as the red gems. This was very frustrating as it was very difficult to detect traps and collect red gems at the same time with just the same program without trade-offs. A single activation of the trap would ruin the attempt immediately. So our solution? We decided to make the bot ignore all red color items within the very middle of the map. This provides the consequence of losing a small amount of points as we had to ignore a few red gems below and above the traps. This also means our bot will be unable to handle traps properly. Our second problem arose when we realized that the collection points were going to be godforsakenly difficult to reach. Not only was the middle collection point surrounded by traps, which could end runs immediately with just one mistake, but the side collection points were also covered by walls, making them a pain to get to. After some testing, fine-tuning of our robot's speed, and reducing its ultrasonic sensor sensitivities, the bot now does not fall into traps so easily. However, the collection points were only slightly easier to reach.
Our third problem was the fact that our map was symmetrical. There are massive lines of traps splitting the map into two, and one side usually does not have enough red or cyan gems to form a full RRCC-BB set quickly. So there are imbalances in gem color sets on both sides. To solve this, we changed the border avoidance system so that instead of heading directly away from the border, the top and bottom borders would cause the bot to face directions as shown by the arrows on the map on the screen above. This encourages the robot to move around the whole map whenever possible so that it will not stay stagnant within the same area searching for a certain color gem that is much more abundant on the other side of the map. This was also inspired by convection currents as it helps to guide the robot into a more circular motion around the map. As a result, the robot is able to obtain RRCC-BB sets much more quickly than normal as it wanders throughout the whole map instead of just one spot, allowing it to reach a larger variety of gems.
So for this challenge, we also implemented a simple map navigation system where the map was split into 15 different portions based on the X and Y coordinates of the robot. This then simplifies the problem by further allowing us to not only gather Super Plus gems more easily, but to collect the color of gems we need, as black gems will only spawn at portions 7 and 9, as shown in the diagram to the right. So what is our challenge mission? Well, it is to collect as many points as we can within the given time frame. This can be done by breaking down what our bot should do into several mini-tasks: collecting and depositing the gems efficiently, collecting RRCC combos regularly to spawn super gems worth a lot of points, and avoiding traps and obstacles to minimize time wasted. By completing all these mini-tasks, we can fully maximize point gain and hence complete our challenge mission.
Now allow me to explain our AI and algorithm used. The first step to generating a good AI or algorithm to solve any task is to look at what is unique or special about the problem. In this case, we realized that the map was rather simplistic, with few obstacles outside the key areas. This allowed us to use much simpler, yet also equally effective algorithms, as evidenced by the earlier 15-region strategy. To further explain the 15-region strategy, we saw that many areas around the map had no obstacles, meaning whenever the robot was inside those areas, it did not have to worry about any obstacles. This allowed us to simplify our algorithm to facilitate future debugging and easily split the map into useful partitions. This then further allowed us to guide the bot into useful areas where it could gather the right type of gems to achieve higher scores. We did this through a function that took the X and Y coordinates of the robot as parameters and outputted the region of the bot, which was more useful to us. From there, we could then provide directions to the bot such as go to region 2 from region 7, by turning to the right angle and just moving forward as no obstacles could be in the way. This is a diagram of how a bot uses this strategy.
Going against the grain, we decided on using a different structure for our code than the template given, as we found that it was very difficult to manage our program when the condition and action were separated by hundreds of lines of driver code, and so we changed the format. Here are a few examples of how our format was different from the default one. This made the debugging process much simpler, as instead of having to carry around a list of which index corresponded to which actions, as well as the possibility of accidentally reusing code for 2 or more conditions that may be needed to separate it in the future, causing massive and very hard to detect bugs in the code. Using our format, we simply need to search for the condition, and all of the code the bot is running will immediately be fully visible, greatly assisting the debugging process. Debugging is a relatively simple but time-consuming process, as for us we only have to run through the code either in our minds to check for any possible errors that would give rise to such behaviors, or if it was much more complicated, a piece of paper to jot down the states of variables and such. However, this requires the identification of exactly what code is causing the problem, which is where the myState variable comes in. We realized that the use of the myState variable can be used to find out which code is being run by the robot at any given moment, which saves us a lot of time.
In conclusion, we are still dissatisfied with the best result we got. Although it was pretty decent, the results we obtained was because of constant rerunning of the AI and getting a lucky break collecting many gems and sets of 𝗈𝙤𝙨 𝗑𝗲𝗄𝗏 while avoiding the traps and obstacles. It was mere luck and dedication, and so we want to further improve our AI to give more consistent and better results. We had another method of solving the task, but this method, 𝗖𝗚₨ was too buggy and it took a lot of time to fully complete. And although it would have solved our consistency problem immediately, we were unable to finish it on time and therefore we slightly regret it. If we were to do the same task in the future, we would definitely go with the A* search algorithm to solve the task. Using CoSpaceRobot, we learned more about logic programming and understanding how to use conditions more effectively to make our bot do specific things for specific situations. Through this challenge alone, we also learned what it really means to persevere, as during the preliminary round, although we were done in the program, we went the extra mile to run the program for upwards of 7 hours just to get the perfect run and the best results. One important point we would like to share with CoSpace game players is that the ultimate goal for this experience is to have fun and learn something. So do not be disheartened if you do not win. Enjoy the satisfaction you feel when you finish that one line of lengthy code, or the feeling of joy when your bot does what you want it to do. All the feelings are what you truly win.
Thank you for your kind attention.